All right, good morning. We are going to start today's lesson by reviewing some of what we explored yesterday, talking about powers of 10. So behind me here, I have all of our place values within our whole numbers and within our decimals. So you'll see our decimal point falls right here. Anything to the left, which is our left, is a whole number. So when you actually write the number, say I write the number 23. 23 is a whole number. Now there is a hidden little secret invisible decimal that falls right here. We just don't write that when we write whole numbers, but it is secretly there. So now that we're going into 5th grade, you're going to see that our numbers actually could have whole numbers with some part numbers combined. But just remember that there's always this invisible decimal. So if I was to write the number 23, you know here we have 3 ones and 2 tens, and this is a whole number. Now if I was to write 2 tenths, there, since I said tenths, the TH at the end of that word, I now am talking about a part of a number. So anything after the decimal becomes part of a number, and that is to the right of the decimal. Okay, so that's a real quick review on whole numbers and decimals and how they fall within the number line and place value. Okay, let's take a moment to review kind of a little bit about what we explored in yesterday's lesson. So we started talking about what exponents are. And exponents are the little number that kind of hangs up on the number 10. And that's where we're talking about powers of 10. So for example, 10 to the second power, that is how we would say it in word form, or say this, 10 to the second power. 10 to the second power, if we were to stretch it out, I'm going to call this like expanded form because I'm going to actually show what this looks like. This is saying 10 times 10. I need 2 tens because the exponent of 2. Now, if I was to write this in standard form is just the number. So I actually need to multiply this. And I can do this by looking at how many zeros there are. And we're going to see a pattern which we should have looked at and kind of reflected on yesterday in our lesson. 10 times 10 is actually 100. Now let's see this pattern. I have the number 2 here. I have 2 zeros here. And in my standard form, I'm given there are 2 zeros. Let's see if this pattern continues. So if we did 10 to the third, that means I need 3 tens, 10 times 10 times 10, and 10 times 10 times 10 equals 1,000. So if we continue that pattern, there's a 3 as the exponent on top of this base number. There's 1, 2, 3. There's 3 tens. And let's make sure in our standard form, which is just the number, that there are 3 zeros. 1, 2, 3. Yes. So your pattern, so you need to make sure that your exponent matches the amount of place values, or zeros in this case, because our zeros are being placeholders when we're dealing with the number 10. Okay, so what we're going to do now is apply what we have explored and develop some more understanding around using powers of 10 when we're dealing with decimals and parts of numbers. So let's take a look at this. You can, if you would like to, this is also on page 137, so you could follow along by multiplying and dividing on the Model-it as well. All right, here we go. So if I was given 5 tenths times 10 to the second power. So here is the kind of rule that you do. When you multiply, we know that our numbers are going to get larger. So it's going to get closer to whole numbers, or actually the decimals are going to become whole numbers. All right. So when you multiply, you move the decimal to the right. That's the right. All right. So I need to I'm going to multiply 5 tenths by 10 to the second power. what I would do is I would rewrite the number, and I'm going to take my decimal. I'm going to use my purple. I'm going to take my decimal and count over 2 place values because I'm multiplying by the power of the 10 to the second power. So 1, uh-oh, my purple died on me. Please flip. All right. 1, 2. And now I have an invisible decimal here. I have to fill in this. You'll see that I moved over 1 place value. So that was one of your zeros. And I moved over another place value, which I don't have a digit there, so I have to fill it in with one of those zeros. Now, there's no such number as 050, but there is a number that's 50. So 5/10 times 10 to the second power is going to equal the number 50. So when you multiply, your decimal moves to the right. That many times that is in your exponent in your equation. So you ask, well, Ms. McNamara, what happens when we divide? Well, when we divide, you are moving the decimal the other way, and our number is going to get smaller. So when you divide, you're going to move the decimal to the left. Let's use the same problem. So I have 5/10 divided by 10 to the second. So when we're dividing, our number's gonna get smaller, and I need to move the decimal to the left, which would be this way. So I'm gonna write it again, 0.55/10, and I need to slide it over 2 place values. There's 1 place value, 2 place value, and now my decimal. Okay, let's think to ourselves. So I had a digit here. I don't have a digit here. I have to put in a placeholder. What digit in our number system is a placeholder? It's 0. So I'm going to plug in 0. So my quotient to this problem would be decimal 0, decimal 0, 0, 5, or 5 thousandths. So my number got smaller because I divided by that power of 10. My number got larger because I multiplied by that power of 10. So using what we just reviewed and learned, actually, when we multiply, we move the decimal to the right that many places based on the exponent. And when you divide, you move it to the left. So let's apply that to this problem. I have some practice problems that we're going to try out. And let's see if this pattern works and if you can practice it as well. So here I have 27 hundredths. Right? So you read it by, you say the number 27, and you say the last place value. And our last place value, this is the hundredths. So it would be decimal. So I would say 27 hundredths because the 7 is in the hundredths. And that you can see it even there. So I'm multiplying. So I know when I think to the rule, when I multiply, I'm adding place values. I'm moving that decimal to the right. And I'm going to move it 2 place values. So let's think. My number is going to get larger. Hopefully it becomes, I'm getting it closer to a whole number. Now I don't have to rewrite this problem. I could just slide this over. And I think to myself, okay, well, to the second power, so I need to go over 1, 2. My decimal is now there. My 0 is going to go away because there's no number that's really 0.27, right? So my 0 goes away, and I'm left with the whole number of 27. Now, if I was to do this same problem, but divide by 10 to the second, so now my number is going to get smaller. The decimal is going to move to the left, 2 place values. So I start here, and I'm going to slide over 1 place value. There's already a 0 there, and that can stay there. There's one of my zeros. And I'm going to move it another place value. I'm going to make my 0. I'm going to make my decimal. Since I have no digit here, I have to fill it with a placeholder, which is a 0. So 27 hundredths divided by 10 to the second power would be 27 10,000ths, because the 7 is in the 10,000ths place value. So remember, you say the place value, the last digit comes is placed in. So for practice problems today, what I want you to do is to try to practice this strategy that we've learned today, that we're developing on a develop day, of when you multiply, you are moving the decimal to the right. Ta-da! And when you divide, you multiply, or you move the decimal to the left, that many places that are up in your exponent. So the next couple slides are going to be some practice problems to see if you can use what we learned today about powers of 10 when you multiply and divide them to decimals.